This video has examples about proving lines to be parallel. And we'll answer three essential questions. What conditions will result in parallel lines? How are lines proven parallel? And how is a paragraph proof written? So first example here, we know that two angles, what their measurements are. So the measurement of angle 1 is 120 degrees here. And we know that the measurement of angle 7 is 120 degrees. Is that enough information to say that lines M and N are parallel? Well, angles 1 and 7, obviously their measurements are equal. That tells us that the angles are congruent. And what are their positions? So their positions are opposite exterior angles, and we know that opposite exterior angles being congruent does prove that the two lines are parallel. Okay, how about measurement of angle 2 being 60 and the measurement of angle 5 being 120? So angle 2 here is 60 degrees and angle 5 has a measurement of 120 degrees. Is that enough information to prove the lines are parallel? Well, if the measurement of angle 2 is 60 degrees, angle 4, the measurement of angle 4 is going to be the same as the measurement of angle 2 because they're vertical angles, so that's also 60. Angle 4 and angle 5 are consecutive interior angles, and we know that if lines M and N are parallel, consecutive interior angles are supplementary. So the 60 degrees of angle 4 should add with the 120 degrees of angle 5, and if they are supplementary, if they add 180, then we know that lines M and N are parallel. So 60 and 120 get us our 180 degrees. So they are, lines M and N are parallel. Okay, what about angle 3 being 112 degrees and angle 7 being 78 degrees? Well, these two angles, angle 3 and angle 7, are corresponding angles. So actually, in order for lines M and N to be parallel, the measurement of angle 3 needs to be equal to the measurement of angle 7. The angles need to be congruent. And in this case, they're not. So we know M and N are not parallel. Okay, how about with these algebraic expressions, can we conclude parallel lines? Angle 2 we're told has a measurement 5x minus 2. Angle 4, which is vertical to angle 2, 8x minus 26. And then angle 8, 4x plus 8. For M and N to be parallel, well, angle 2 is definitely congruent to angle 4 because they're vertical. But for M and N to be parallel, we know that these angles also need to be congruent to angle 8 because angle 8 and angle 4 are corresponding angles. So if we can say that these angles' measurements are all equal to each other, then we can conclude parallel. So we know 5x minus 2 has to equal 8x minus 26 because those two angles are vertical. So solving for x, we get x to equal 8, which tells us that the measurement of these angles, let's take angle 2 for instance, the measurement of angle 2 is 5 times 8 minus 2, so that's 38. The measurement is 38. Angle 8 here has to equal 38 in order for lines M and N to be parallel. So 4 times 8, we're substituting in 8 for x, plus 8 gets us 40. So 38 is the measurement of angles 2 and 4. 40 is the measurement of angle 8. So we can conclude lines M and N cannot be parallel. Okay, one last example, and that's to write a paragraph proof. And we're given information about this diagram. We know that R and S are parallel, and angle 1 is congruent to angle 3. We want to prove that P and Q are parallel by writing a paragraph proof. Now I'm going to do my best here in the space to write this paragraph proof out in words. But let's talk through how we're going to do that. So if R and S are parallel, then P and Q are both transversals that carry all the angle relationships that transversal that cuts two parallel lines carries with it. So, so I know that angle 1 is congruent to angle 3 because it is given. And angle 1 is actually also congruent to angle 2 because these are corresponding angles. If you look at R and S as parallel lines and line Q here as the transversal, angle 1 and angle 2 are congruent because of the corresponding angles postulate. Okay, so we know that angle 1 and angle 2 are congruent because of the corresponding angle postulate. Since angle 1 is congruent to angle 3 as well, we now know that angle 2 is congruent to angle 3 because of the transitivity property of congruence. So we knew angle 1 was congruent to angle 3 because of what was given. Angle 1 is congruent to angle 2 because of the corresponding angles postulate. By transitivity, that makes angle 2 and angle 3 congruent. Well, if angle 2 and angle 3 are congruent, you can see their position. Their position are alternate interior angles. If we look at P and Q cut by the transversal R, now we see that 2 and 3 are alternate interior angles, with P and Q being the parallel lines. And so by the alternate interior angles converse, P is parallel to Q. And that's our paragraph proof.